Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Fred Shankleberg. And Carl, this is one of those many circumstances I have with Kirk more often, is that we start chatting about, just whatever. And then it was like 10 minutes into it, it's like, oh, we got to hit record.
Should hit the record button.
Because you just mentioned a question you got, a series of back and forth emails, and you ended up with this really interesting topic. And then I said, wait a minute. We got to hit record.
Well, let me introduce it again. So we'll kind of do our preliminary discussion, but this time under recording.
Yeah.
Is I get, just for listener knowledge, I get maybe 3 or 4, sometimes more questions per week on FMEA, because I make myself available to any FMEA application questions on the effectivefmeas.com email. And so it's kind of fun. I enjoy it. But there was one question that would have taken more than just a question and answer. It would have involved more consulting work and stuff, because I really wanted to dive into it with the person. But let me bring it up as a podcast topic. And what it is specifically is a process FMEA, which can be, of course, on assembly process or manufacturing, but a particular process step and other process steps, so I'll say plural process steps, that this application or this team wants to use the PFMEA as a failure prediction of what kind of problems they're going to have. In other words, a numerical prediction. And then later, when you get into pilot or trial production, to verify whether or not that prediction was accurate and whether it's attended to. And so my initial thoughts are, the first part of this is the occurrence ranking in a PFMEA is usually not a numerical prediction. There can be some guidance numerically, like 1 in 100, 1 in 1,000, but it's qualitative. In other words, you don't have numbers at this point. And so I use the occurrence in a PFMEA and a DFMEA for the purpose of ranking issues to decide what you're going to fix and what's going to have a recommended action. I don't use it to get a failure rate. So that was the first thing. Yeah. And we'll get your reaction, and then we'll go to the second part of it.
I remember, and I know that you were in the auto industry for much of your careers, but I remember early on, one of the FMEA pieces out of the auto industry was that you use the occurrence with using real data as much as you possibly can, or go get the real data. And I think I heard it explained at some conference that it was intended to be so that the folks working on the dashboard would use the same occurrence relative rankings as the people doing the transmission. And then when you rolled it all up, then you would have apples to apples comparisons, because everybody was using the same occurrence ratings and had to support it. And I thought, I think that's really missing the point, because the person doing the rearview mirror inside the car is going to have all occurrences of 1. And then occurrences meaningless for them as a team to make any improvements. And that's within their scope, is to work on their part of the deal, make the best product they can. But when you compare it to a brand new suspension system that's never been used, and it's all occurrence ratings are unknown, and so they go up to 7, 8, 9, 10, you'll never get funded to anything. But but the business models are such that they still need to make a profit, and they still need to make a good product, and they still need to make something that doesn't fail a lot, at hardly ever. So that's my first reaction, is when it's forced, it's even worse. But using it as a prediction, saying, oh, before we commission this line, here's our expectation for a failure rate. Is that acceptable or not? I think that's misguided. I think there are other uses for an PFMEA in that lineup of what to expect, but I don't think it's going to say we're going to have a scrap rate of X. That I think is pretty much nonsense.
Yeah, you bring up a lot of raw material here for discussion. So and of course I've spent many years in the automotive years ago. Um, and I've seen this happen where it's almost like an accounting application of FMEA. Let's use it as an accounting to get occurrence rankings of all the different 10,000, 15,000 parts in an automobile, and have it all on the same baseline and all apples to apples. That is not the purpose of FMEA. First of all, like you say, it's misguided. I'll give you another view as to why I think it's misguided. I want to get FMEA done early in the product development process. I want to have the FMEA guide the design. In other words, make design improvements while the design is fresh. And I want the FMEA to guide testing. And so, yes, we have warranty and field data as input. So you have data, but you're doing the FMEA. Unless you do FMEAs on everything, which is a different subject, and I don't think it's I don't think it's advised. Unless you're doing them on everything, you're going to be doing FMEAs on the higher risk areas where you have new technology, new applications, other new things,
and so lots of unknowns.
Data,
you have a lot of unknowns.
Exactly. So the occurrence rating doesn't really become a hard number at the time frame when you need to do the FMEA. That's what my thoughts were on that part of it.
Yeah. When it gets forced ranked like that in common scale across the vehicle, for example, that poor rearview mirror, even though they have a new heater element in it to defrost it, it's going to have severity ratings of 1 and occurrence ratings of 1, detection ratings of 1. It's like, I
remember being on site at a company that made exhaust systems, helping them with an FMEA and saying, okay, do we rate? They were asking, do you rate the occurrence of our exhaust system based on the same apples to apples as the brake system, and et cetera, et cetera?
Right.
And I said, no, what we want to do is use the severity, occurrence, and detection, if you use it, to improve your product, make it safe. And but I'm not trying to compare the occurrence between all the different systems and subsystems. I think that's more of an accounting procedure that's outside the scope of FMEA. I want to, within the scope, use it to improve the product and rank.
Right.
And
I had one team that they just decided that, we have this guidelines, so we're going to use that. So everything was 1 in 1,000, kind of roughly scaled on their ranking. Everything was a 3. And they said, well, why don't you just rescale this? Make it 1 in 1,000 is a 1, and 1 in 10,000 is 10. And then, go like that. And they were like, well, we don't have data for that. He says, well, you just listed 15 different things that you need an occurrence ranking for. Are they all exactly the same? And everybody in the room went, oh no, this one's more and more, this one's more, this one's more. But they wouldn't change the scale. And so I said, all right, you guys are all engineers. How about we make a decimal point? It's 3.1. And is this one higher or lower than that one? All right, well, that one's 3.2. And, and they were okay with that. And it was, okay, come on, guys. But I think you're exactly right. It really is a forced ranking. And the more you don't know, the harder it is to actually put real numbers behind it. And it's not the point. It's really not the point. Now, there is value in using a PFMEA, though, to say, well, where do I need to go look? And I think hopefully is going to be your second topic.
Yes. Let's go into the second topic, because the purpose of that PFMEA is to improve your manufacturing and assembly process, to make sure it's safe, that the operators are safe, that the end product is safe, and to have the end product reliable, to meet requirements. There's a lot of purposes. It also guides the process control plan, where you have certain significant process characteristics, product characteristics that become part of the process control plan. So there's a lot of purposes, but I don't think we want to make the primary purpose of the PFMEA to create a failure rate prediction of a process and then go see if it's verified.
Well, yeah, when you first mentioned that as part of this discussion you're having with this listener, is what I didn't get out of the first description was, well, what else are they doing? How else are they using it? Was this in the context of they wanted to feed back onto their team, how well do they understand their process and how well are they making judgments about potential occurrence ratings, right? So I think there's value there,
Mm-hmm.
right?
Just to clarify that point, I think they wanted to make it a closed loop system, which is this process. We predict we're going to have this kind of problem and failure rate. And then 6 months later, we're doing a trial production and we're finding that we're having a much bigger problem or a much lower problem.
And that has value, though. It is the feedback to the team, because if you're sitting in a room and you're looking at a drawing for a new production line, you're bringing in all your experience. But when you create the new line, the experience only goes so far. You got to go see what's going on. And then you feed that back. I think it adds the value of keeping people's minds open and I think that's a value. But when it goes to the ops manager and says, are you going to have a 2% defect rate and scrap rate or whatever, and then they bank on that, I think that's where it crosses the line and going, no,
yeah,
let's
go. I'm going to agree that there can be value. I have no problem with an FMEA being updated. In other words, you start an FMEA very early on, and then maybe a few months later you update it, and then you start getting some test data, and you can update it if you wish. Or in the production world, you can look at defects and update. What the problem I have is if that becomes your means of verification, because the verification of a manufacturing process is very important. And let me give an example to listeners. Let's say you have you're doing a O-ring installation. So you put an O-ring in, you might lube it or put some type of sealant, and you want to create a good fit. Maybe you have a gas fitting or gasoline, and that would be important, of course. You don't want to spill. And so the scenario A is we do a PFMEA. We predict what the O-ring process how it will fail, and we maybe get an occurrence ranking, and then we go in and we check to see if it's failed or not in some way, and then close the loop. My contention here is there's more you can do than just the PFMEA there.
Well,
you may have certain type of
there's more you should do. Yeah, definitely.
Exactly, there's more you should do in order to make sure you have a verified process. You have end-of-line testing. That can be pressure testing, for example. In this particular example, you can do Haas type testing, highly accelerated stress screening, different techniques. And the myopic view is that FMEA is everything. And I've worked with people that think the FMEA process is all we need to do.
Well, yeah, I think there are a whole raft of different techniques and methods that we have out there that people say, well, that's all you need to do. HALT is a classic example. There's a handful of practitioners. Well, that's all you need to do. You don't need to do anything else. But I think, and I think we're going to agree on this one, is that you do the FMEA and you go, all right, here's the top 10 things we our leading occurrence in high scores, and these are areas we need to concern about. At first, it's what can we do in design to mitigate those right off so that we don't even have to go deal with it. What I've always found, though, is that I would star or flag the ones that in the discussion there is like, no, that's an occurrence of 3. And then somebody else, another camp is, no, that's occurrence of 8. And they don't come to consensus on it. They chat about it for a few minutes, and then they don't concede that, yeah, the other one's right, or there's more information available or whatever. So I start and say, we need to get more information. And it might take until you run the pilot to go figure it out. But what it does for me, I think one of the outputs of an FMEA is not just the rank ordering, it's where do we need to go look? What do we need to go measure when we start, building prototypes or running the line? I think there's a lot of value in that because it peels away at the uncertainty. And one of those two camps is probably right, or there's a third option that neither of them is right, and we learned something that nobody knew. But if we just ignore it, if that uncertainty even though it doesn't rank at the top of the list, it had a big uncertainty. So I said, we need to learn something here. And then, time and resources permitting, we go measure that part, or we monitor that part.
I'm agreeing with you that I think you've said it very well. I would use the linkage between a PFMEA and a process control plan. And the process control plan is the manufacturing analogy to the design verification plan. So the process, and it's not the same as the FMEA.
Right.
And neither is the DVP the same as the DFMEA. And so we need to have the PFMEA done and input to the process control plan. Then we're going to measure and control and do SPC and anything else we need to do to make sure the process steps are capable and in control. And we don't want to lose that step by just saying we're going to verify the PFMEA occurrence number. I want to actually do a process control plan and make sure that we measure the right things. And like you say, point to the most important things. I call them significant product characteristics or significant process characteristics.
Yeah.
And all that is part of the process control plan. So my whole point of that I'll get back to this gentleman and share with him is that we want to do more than just check to see if the occurrence ranking is okay when you get to production.
Yeah.
You want to actually have a full process control plan and measure the right things and make sure you're capable and in control. That was the long answer that I couldn't do on an email.
Yeah. Well, there's so many things that we do that feed into other parts, FMEA feeding into the control plan. I do remember I was at a factory that made circuit boards, and we were assessing them as a potential supplier, and they were very proud that had done PFMEAs, and they were very happy with that. And what'd you learn? What are the areas? And they listed like the repair, the touch-up spot after the surface mount soldering. They had a table where they had people looking for areas that were prone or likely to have cold solder. And so they touch it up with a hot soldering iron, which in my mind just causes all kinds of other problems, which they didn't explore at all, which was one issue. So what are you using the FMEA for? And it was exactly your scenario. It's like, well, we know that we need to do SPC because, you guys, they were kind of looking at us going, well, you expect us to do FMEA and SPC. And I says, yes, I expect you to do that where it makes sense. And
yes,
they didn't get that part. So they bring me out onto the line, and the first thing they show me is this beautiful SPC software that's laser measuring the solder paste deposits and everything else. And it goes, was this on the FMEA at all? Is this an issue or a problem or an area that needs monitoring or control? Oh, no, we got this so under control. It's, blah, blah, blah. And it's like, well, what about that touch-up section that you guys did identify as a top issue? What are you doing there? Oh, nothing. This is easier to measure. And, okay.
Whoa.
We need to talk.
Yeah, we need to talk. Well, and one of my pet peeves, to use that phrase, is where and there's a whole group of people that are actually believers in this, that the FMEA is all you need to do. Or the FMEA is going to do more than it's designed to do.
Right.
And this group of people will think we can do FMEAs on everything. So they're looking at complex machinery or equipment or aircraft or automobiles, and let's do FMEAs on everything. And then we can use the FMEA as our means of validation, because all the requirements for the entire system and all the components will be in this giant FMEA.
Yep.
And the thing I've learned over many years is, number one, the FMEA will not be valuable because you're not focusing on the areas that are most important. And so the team is going to get overworked. They won't have time. So you end up in a poor quality, big, giant FMEA. I'd much rather do fewer FMEAs on the higher risk areas. And you end up with this giant FMEA, which I think is a waste of time, in my opinion. So this whole subject of making one tool do more than it should is just an interesting topic. Like you brought up, HALT is another one, and I'm sure I remember reliability growth used to be the big tool, let's design it. During development, we'll build a bunch of parts and we'll grow the reliability, and that's essentially all we'll do.
Mm-hmm.
That doesn't work.
No.
You run out of time, for one thing.
Well, yeah, unless you're a military contractor and you got a 12-year ramp to build a widget. So
military is changing; they're getting so much better on this.
Yeah, no, I agree. It's I don't know what causes this kind of discussion. It might be the bright new shiny thing, or they did an FMEA and found it really, really usful, and like, let's double down on that and do it all more intensely, more expansively. Let's do it everywhere. I think part of it is that success in one circumstance without really understanding why it worked, because it was such an area that really had no prioritization, no critical look at their design or whatever else. You could have done a design review. If you did it well, you would have a great success also, because it was so easy to find things to actually make improvement and then track it and do it. The hard part is learning enough to connect these things. And that takes being familiar with FMEA and HALT and ALT and process control and in the whole range, all the tools, and how they fit and feed into each other.
What's the selection criteria? And this comes back, and I know we're probably wrapping up this podcast, but it comes down to what we talked about in our book, which is you don't just do automatically certain reliability methods. You get a vision for reliability, you get a gap analysis, you understand what your decisions are that need to be supported, and you select the vital few tools rather than a hobby horse of one particular tool that you've always used before.
Mm-hmm. Yeah. Oh, there's a whole nother topic here.
Yes,
I'll bite my tongue. But so hopefully this addresses a couple of the key points for your person that was asking questions. But I think I agree with you. At some point, what appears to be just a question that sometimes we can answer a question and give you the reference or whatever in, a couple minutes or 20 minutes or something like that. But when it becomes, this really needs a good long discussion, and I need to know more about what's going on in your program and process and so on. And then it's consulting. But like you, it's fun and educational to hear the questions and to respond to them and help people make a difference in these light touches. But sometimes, it's a bit more complicated and we need to talk to it. So that's a good source for podcast discussions. I like that.
It is.
Yeah.
All right.
Well,
cool. If you're a listener and you have some subjects that are a little knotty or complex, and you'd like to get some discussion about it, put it into a question. If we can answer it easily, we will. Otherwise, we'll maybe make it a topic for a podcast.
Or both. Sometimes we get some cool questions that we certainly can expand on.
Yes,
it's no problem. But head over to accendoreliability.com/go/SOR, and you can find a comment form and a way to record a message to us. Or you could find Carl and I and the other hosts of the show on LinkedIn or on our About pages. There's plenty of ways for you to get in touch with us. And as usual, we certainly do appreciate hearing from you and hearing your questions and what's working or not working in your area. And then we'll talk about it.
Absolutely.
That's what we do. So thanks for listening and have a great rest of your day. And thanks, Carl. We'll talk to you again soon.
See you later, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.